Okay, hey, on it's kind of a rainy day. All right, on these, we've got some little tricks we can do, and we talked about it a little bit. But the thing is, on this particular one, okay, on this one, the five theta, sorry, the five theta, we are totally stuck with. All right, so we can't change that. However, I can change this two. All right, and you're like, well, how can I do that? Well, I can just divide by five, as long as I multiply by five somewhere. Okay, so by the way, direct substitution. If I substitute the zero in, that's zero. On top zero, sign of zero, zero, zero times three, and on the bottom two times zero. Okay, so it's definitely one that has a removable discontinuity. Okay, but the way we remove it is by using these two properties up here. Okay, the sine theta over theta and the cosine theta over theta. But more specifically, we're going to be doing this one right here, where as long as it's a multiple and they're the same, we're good. Okay, so here we go then. On this particular one, what I'm going to do is I'm going to kind of factor out things I don't need. All right, so it's a constant multiple rule. I can factor out of three halves. All right, so three halves is coming out, and you're like, where'd that come from? Well, that's that three and that two. I don't need them, so I'm going to remove them or just factor them out, because with a limit you can do that. You can multiply, divide, and just factor it out, and you get the same limit. All right, so I'm approaching zero, of course. And now I've got something I'm stuck with. So I was totally stuck with the sine phi theta. I mean, yeah, there are trig identities and stuff like that. We're not going to mess with those. We're just going to have these match up uh, a different way. Okay, so there we are. Okay, and so on the bottom, I just have theta because of the factoring that we did. Okay, so that's good. Frozen. Okay. Good. Okay, now, so let's change down here to different colors so you can see it a little bit better. This thing is kicking in and out. There we go. Okay. All right. So what I need on the bottom is a five, so that these two will match up, and then that limit will be equal to one. So but I just divided by five, didn't I? So to make up for that, I have to multiply by five. Okay. So this is 15 halves. Okay. And this is one. This limit right here is one. Okay. So of course the answer is 15 halves. And you may be thinking, I can kind of see that in the original problem. Yeah, that's true. That's true. You can kind of see it. That right there is going to be five halves, and then the five up top was multiplied by three. Absolutely, that is not incorrect. And so, if on a multiple choice problem, you didn't want to have to go through all this work, you could immediately select the answer. Now, this one, again, let's make sure that we're getting a zero over zero. Cosine zero, if I do a direct substitution, is one. That's one minus one. The sign of three times zero is zero, all over zero. Yes, it is. So what we're going to do is, in this case, since I have a common denominator here that I'm actually quite fond of, we're going to separate those two and use the limit property that allows us to separate any addition and subtraction. So I'm going to separate it in a convenient way so that it looks like the the common limits that we have up here. Okay, so I can see then that I've got a 1 minus cosine. I need those to go together. And then the sine by itself. Okay, so here we go. So I've got a 1 minus cosine. That one I like. We know what that one is. We don't have to do anything to that. Plus, and that's that addition sign right there. Okay, that one right there is coming down. The limit, distributing this limit. I think that's a proper thing to say, that we're distributing the limit. There's nothing wrong with that. Of sine something we're stuck with over something we can manipulate. Now, you probably have noticed by now kind of what's happening on these. That's going to be 3. But to prove that it's true, I need a 3 right here. To make up for that, I'm going to factor out. I mean, I could put it up top, but I'm just going to go ahead and factor it out. That way that's 3 over 3. This limit now, because those two are identical to one another, or go to 1. So it's 3 times 1. And you're probably thinking, man, can I just say it's 3? I think you can. And then this one is the cosine one, and it's always 0, regardless if those two are the same. Okay. And I've never had a professor or anyone really talk about those two, but it's true. It doesn't matter what they are. It's going to go to 0. But over here, it does matter because you're talking about 1 rather than 0. All right. So the answer is 3. Yay.